Hello students, next let us look into some of the numericals using properties of Z transform. So using properties of Z transform, find the Z transform of the following signals. So we first start with x of n is equal to u of minus n. Now how do we solve this? See, we have already studied the property of time reversal. So what we will do is first we will find out the Fourier transform of u of n, which we already know, and then from there we will use the time reversal property to find out the Fourier transform of u of minus n. So let us do it step by step. So we know that u of n, the Z transform of u of n, is basically given by z divided by z minus 1 with ROC. We have to write the ROC with ROC z greater than 1. Why greater than 1? Because the ROC should be outside the circle. Why? Because we want to go for a right-handed sequence. So u of n is a right-handed sequence, and this is what we have already studied of the Z transform of the basic signal u of n. Okay, next we will apply the property of time reversal. And what is the property of time reversal? The property of time reversal says that if you know the Fourier transform of x of n, then the Fourier transform of time reversed x of minus n will be the original x of z converted to x of 1 by z. That means wherever we are having z, change it to 1 by z, and the ROC is also given with it, and the ROC is also reverse. That means ROC is 1 by r. ROC is made 1 by r. Therefore, using this, we will write u of minus n. Therefore, we'll have a Z transform. So what is the original x of z? This is the original x of z, which is z divided by z minus 1. So instead of z, what we will write? We will write 1 by z. So I will write 1 by z, 1 by z minus 1. So what I have done? I have taken this original, Z transform, and instead of z, I have written 1 by z, which now gets converted into, the denominator will become 1 minus z, and the numerator will become 1 by z multiplied with the z from the denominator, which is z. So both of them multiplied, I will get 1. And for making the denominator z minus 1, I will write a minus on top. Okay, why? Because to make this 1 minus z into z minus 1, I have to multiply with minus 1. So I will multiply both the denominator and numerator with minus 1. So in the denominator, what happens is this becomes minus 1 plus z, which I can write it like this. Okay, so that is what we have done. Now you can straight away write 1 divided by 1 minus z. That is also not an issue. And then what about the ROC? The ROC itself also will get a change. So the ROC will now be, instead of z, I will write 1 by z. 1 by z, let me write that properly. 1 by z greater than 1, or z magnitude less than 1. Therefore, finally I will write the answer. Finally I will write the answer as u of minus n Z transform will be minus 1 divided by z minus 1 with ROC being z less than 1. That means inside the circle. And you can see that this is actually a left-handed sequence. It's not a right-handed sequence. Now it is a left-handed sequence. And the ROC of the left-handed sequence is also always inside the circle. So that is what has happened here. Let us look at the next problem, B. B is x of n is equal to u of minus n plus 1. So how do we find out the answer for this? So let me solve it. So we know here what we will do is we will first find out what is the Z transform of u of n, and then we will find out the Z transform of u of n minus 1, and then I will find out the Z transform of u of n. I will first find out u of n, and then I will find out u of minus n, and then I will try to find out for the case of u of minus. Now instead of n I will write n minus 1, which actually is what? U of minus of n plus 1. So many will think that first I will try to find minus 1 and then I will try to find shifting plus 1. No, if you remember, there is a there is a order in which we do scaling, shifting, reversal. There is an order which we have already studied, so we have to go in that same order. So generally what we will do is we will basically write it like this. So remember it, once you do minus n, then you have to do a change in n itself. So what is the change in n that I have to bring? I have to bring a change in n as n minus 1, then only totally it will become u of minus n plus 1. That we have to take care. So based on that, first I will write, we know that u of n gives a Z transform of z divided by z minus 1 with ROC z greater than 1, that is outside the circle. Okay. Next, we know the time reversal property, which says that if you are having a function x of n whose Z transform you know, then the Z transform of x of minus n will be x of 1 by z, that means replacing z with 1 by z, and the ROC will be 1 by r, that means the region is reversed. Okay, so for using that, therefore I will write, therefore u of minus n is going to have a Z transform of, instead of z I will substitute 1 by z, then 1 by z minus 1, which is equal to, if you remember just now we did minus 1 divided by z minus 1. What is the ROC? ROC is 1 by z magnitude greater than 1 or z less than 1. Correct? Next property that I have to do is, see, next, as you see here, next I have to do time shifting. So next I will have to do time shifting. Okay, now if I have to do time shifting, so I will apply the time shifting property. What is the time shifting property? The time shifting property says that if you are having a function x of n whose Fourier transform you know, then x of n minus n naught, the Z transform will be z raised to power minus n naught, okay, z raised to power minus n naught, x of z itself, okay, but now the ROC is changed as the original ROC with addition of an additional 0 or additional origin or infinity. Okay, but based on that, let us write now. Okay, so based on that, what I'll write, I'll do it in the next page. So what I have to do, all I have to take the Z transform of U of n, which is this one, and then I will have to multiply it with z raised to power minus n naught, where n naught is the shift that I am bringing. So what is the shift I am going to bring? See, I am having u of minus n, and now instead of n, I am going to write it as n minus 1. Correct? As n minus 1. So for that, first I will have to multiply with this z raised to power minus 1. Okay, so that I will write in the next page. Therefore, I will have u of minus n within bracket n minus 1. Okay, so that the z transform will be z raised to power minus 1 into minus 1 divided by z minus 1. Correct? And what about ROC? The ROC will remain same as for this one. But now since this is there, that means z inverse is what? 1 by z. So now if this has to be infinite, in that case z should be equal to 0. So z is equal to 0. At z is equal to 0, this function will become infinite. So z is equal to 0 cannot also come in the cannot come in the region of convergence, because if the value of z is equal to 0, then this will not converge. So what was the original ROC previously? See, the original ROC as we have written here is z less than 1. That means the ROC is within the circle, inside the circle of radius 1. But inside the circle of radius 1, which I will draw here, roughly I will draw here. Suppose if I am going to draw the ROC for the circle inside radius 1, so suppose if this is 1, then inside radius 1 means I am going to draw this whole circle inside. But see, the origin is there included without the origin. So I will have to negate the origin out of it, because if the value of z is equal to 0, then according to this equation, which is basically from z inverse, we can see that the the value will basically become infinite, or it will not converge. So what I will write is ROC is same, that is z is less than 1, but we have to avoid 0 except z is equal to 0, except z is equal to 0. Now this can also be, I can further write this as u of minus of n plus 1. The z transform is going to be this, I can write it as minus 1 divided by z into z minus 1 with ROC z less than 1 except z is equal to 0. Okay. I can do the same problem also in another way. That means I can first find u of n, and then I can go for u of n plus 1, and then I can go for u of minus n plus 1. So what is happening here? Here I am having time shifting, and here I am having time reversal. I can write it like this. But see, here the shifting is now plus 1. Let us see if the answer we are going to get is same. See, u of n, the z transform will be, if you remember, it will be z minus 1 with ROC. If you remember the ROC is z greater than 1. Now if I apply the time shifting property, according to the time shifting property, all that is going to happen is I will multiply z raised to power 1 with the original x of z. Original x of z is what? Z into z minus 1, isn't it? So it will be as good as writing z square. Okay, and what is the ROC? ROC will be, since there is a new z that has come, see there was an original z, so now the new ROC will be same. The ROC will be same because ROC is going to be equal to z greater than 1, okay, but I will have to not care of origin here because now z is in the numerator. Okay, next what is going to happen? Okay, next what is going to happen? What is going to happen is time reversal. So what happens in time reversal? Time reversal, I have to write wherever I am having z, I will have to write 1 by z. So here it will become 1 by z square divided by 1 by z minus 1, which becomes 1 by z divided by z square, divided by 1 minus z, and the denominator z will go on top and it will multiply here, which will get cancelled with one of the z, and what I will have is 1 by z into 1 minus z, which I will write it as z minus 1, so that a minus 1 comes on top. And see, this answer and this answer, both of them are same. Okay, and what is the ROC? ROC has to be also changed. So here I had said that ROC is greater than 1 with a exclusion that since another z is getting multiplied, so z is equal to infinity has to be avoided. Okay, except z is equal to infinity. So here also the ROC is going to be, ROC is now going to be, instead of z I will write 1 by z should be greater than 1, and 1 by z should be equal to infinity. So what I will get? I will get z less than 1, z less than 1, and here it will become z is equal to 1 by infinity, which is equal to 0. So z less than 1 except, so here it was except z is equal to infinity, here it will become z less than 1 except z is equal to 0, and that is the same answer that we have got here, correct? So it does not matter what is the order here, because here when we have taken the order, we have taken care that when we apply time shifting, we apply it to n, and when we are applying time reversal, we are only applying time reversal to n. Okay, next see, x of n is equal to u of minus n minus 2. See, you can go either like first do u of n, first find out the z transform of u of n, then trying to find u of minus n, and then try to find u of minus of n plus 2. So sorry, I should have not drawn this arrow here. The arrow should be this. Okay, so here you are having time reversal first, and then you are having time shifting. Because you have put the bracket here, so this becomes u of minus n minus 2. Okay, now you can also do like this: u of n, first you will find out, then we will try to find out u of n minus 2. So what is this? This is time shifting, and then we can find out time reversal, which is u of minus n minus 2, because we have applied time reversal only to the time function, which is n. Okay, so these two methods we can do. We will do the second one here. So the solution is, first we know u of n the Z transform is Z divided by Z minus 1 with ROC magnitude of Z greater than 1, that is outside the circle. Next, we apply the time reversal. Apply time reversal, where what is time reversal says? Time reversal says that if you are having a function x of n whose Fourier transform, Z transform you know, then the Z transform of x of n minus n naught will be the original x of z multiplied with z raised to power minus n naught, and the ROC there is only a change, there is no change. Only change is either the addition or subtraction or a deletion of z is equal to 0 or z is equal to infinity. We will see here. So next, u of n minus 2 is the next step that I will take. So here, based on that, I will get z raised to power minus 2. X of z is z divided by z minus 1. Where what is the, so let me reduce this also. So this can be reduced as z inverse. So this will become 1 divided by z into z, sorry, z into z minus 1. Okay, what is the ROC? ROC is the same, z greater than 1, but since now we have multiplied with z raised to power minus 2, which is actually 1 by z square. So because of this z being in the denominator, I can say that if z is equal to 0, then this will become infinity. So I will write except z is equal to infinity. Sorry, z is equal to 0. Because at z is equal to 0, this function will become infinity. You can see from here itself. Okay, so so based on that, we have got the function. Next, we will use the time reversal property. So I will write apply time reversal. Apply time reversal. Sorry, this was time shifting. Sorry, this was time shifting, not time reversal, time shifting. And this is time reversal. So time reversal says that if you are having a function x of n, then for x of minus n, the z transform will be obtained by just changing z to 1 by z. Okay, and what is going to be the ROC? ROC is going to be just 1 by r. That means there also you have to put 1 by z. So let us do that. We already know u of just the previous one. So u of, for the case of u of minus n minus 2, the z transform will be, so instead of z I will write 1 by z. So I will get 1 divided by 1 by z into 1 by z minus 1, which is what? Which is z divided by, and here it will become 1 minus z, and then one more z in the numerator will come. So z square divided by 1 by z, which I can actually write, since I generally always write it in terms of z first and then the constant, whatever is the constant, since I write always like that. So I will write here also, I will write z minus 1, so that a minus goes on top, and I get z square. Okay, I get z square. You can write it like this, this is not a problem, but generally I will always write like this because that is the standard form of writing. Okay, what about the ROC? ROC will be same ROC, but instead of Z you have to write 1 by Z. So ROC will be 1 by Z magnitude greater than 1 except Z1, sorry, here also it is 1 by Z, so here also except 1 by Z is equal to 0. Okay, so for that, if I am going to rewrite it, then u of minus n minus 2, the Z transform will be minus of Z square divided by Z minus 1 with ROC. Now from here I will get Z less than 1 except now here there's a small mistake I have done. Nothing. See, here it should be outside the circle, so there is no point in writing except Z is equal to 0, because Z is equal to 0 is anywhere not there in the ROC, isn't it? See, when I am going to draw outside the circle, the outside circle ROC basically draws like this. So it is like this, and then the ROC is outside. So already Z is equal to 0 is not taken. Okay, so there is no point in writing that. Okay, there is no point in writing that. I am sorry. So here also I will not write like, and here also I will not write that. So this is basically what is the ROC, and this is basically what is the answer. So next, x of n is equal to 2 raised to power, not 2, let me write something less, 1 by 2 raised to power n minus 2 u of n minus 2. Okay, so how do we solve this? Again, you can see that first I can find out for the case of 1 by 2 raised to power n u of n, and then I will apply the time shifting property, and I will find out for the case of when n is shifted by minus 2. So n is minus 2, n minus 2, and u also gets changed to n minus 2. Okay, so it's just a one-step problem, so we will do it fast. So already I know, we know that if we are having a raised to power n u of n, the Z transform we have already found out for this as Z divided by Z minus a with ROC, which is, this is a right hand side function, so its ROC is Z greater than magnitude of a. This is what we have already studied, magnitude of a. So therefore for 1 by 2 raised to power n u of n, the Z transform will be Z divided by Z minus a. Here a is 1 by 2. Now remember, just for your sake, if I am going to write it as 1 by 2 minus 1 by 2 raised to power n, instead of writing Z divided by Z by minus 1 by 2, I will write Z divided by Z minus of minus 1 by 2, which will become actually Z plus 1 by 2, and same change will occur also in the ROC. Okay, now what is the ROC here for this case? Here the case of the ROC is that magnitude of Z will be greater than the magnitude of 1 by 2, which we know that magnitude of 1 by 2 is again 1 by 2 itself. Now instead of 1 by 2, if this was the case, which is minus 1 by 2, then also I would have written Z greater than magnitude of minus 1 by 2, which is actually what? Which is 1 by 2 itself. So in that case also the answer of ROC would have been the same, that it is outside 1 by 2. So anyway, the problem is not this. This is the equation for now. So this is what is the ROC. Next we apply the time shifting. So applying time shifting. What is the time shifting property says? Time shifting property says that if you are having a function x of n which is shifted by x of n minus n naught, then the z transform of that is the original x of z that you have found out multiplied with z raised to power minus n naught, and the ROC remains the same other than any new origin or at infinity. So let us look at that. Therefore for the case of 1 by 2 raised to power n minus 2 u of n minus 2, so both those are getting shifted by minus 2. So all I have to do is I have to take this one and I have to multiply with z raised to power minus 2. So let me write that clearly. Z raised to power minus 2 into z divided by z minus 1 by 2, okay, z minus 1 by 2, which I can write it as this is going to be equal to 1 in the numerator, the numerator it will be only 1 divided by z into z minus 1 by 2. Now since we have got a new z in the denominator, the ROC should have been avoiding z is equal to 0, isn't it? But let's look at what is the ROC. The original ROC is this. Basically the ROC will remain the same, which is magnitude of z. I have to write ROC. So ROC is going to be magnitude of z greater than 1 by 2, which was the original. But that if I would draw the ROC greater than 1 by 2 means I have to draw it outside, isn't it? But now you can see that there is nothing in the origin. The origin is already not in the ROC. So here the value of z becoming 0 will never occur because the original ROC itself is not that. So basically we can write from this that this is the answer itself. The ROC is z greater than 1 by 2, and this is the complete answer. Next problem, E. So the next problem, what we are going to do is we are going to, let's take a case, write it a little bit more down. So E is x of n is going to be equal to, so now just have a look here, is going to be 2 raised to power n, okay, or let me take the previous example itself, 1 by 2 raised to power n, okay, and u of n minus 2. Now how will we do this? See, there are two methods of doing it. One is you find out u of n, what is the z transform, okay, then you find out what is going to be for u of n minus 2, that is time shifting. Sorry, this is not the arrow should be this, okay, and for this step it is time shifting, okay. Next you multiply with a raised to power, here a is going to be 1 by 2 raised to power n u of n minus 2, which is this property. This property is basically, if you remember, multiplication by an exponential sequence property, the third property that we had studied. It's multiplication by an exponential sequence property, which basically says that if you are having a function x of n whose z transform you already know is x of z, then if you multiply it with a raised to power n, then the z transform will be, sorry, I should write n, then the Z transform of that will be x of capital X of, instead of Z you have to write Z by A, with ROC also becoming multiplying the region with A. Okay, so you can use this property, you can use this method, or another method is see, you can multiply and divide this whole function x of n itself. You can multiply it with 1 by you can divide it with 2. That means if I am going to write 2 raised to power minus 2 and multiplying, okay, then in that case I will have to divide also, that is 2 raised to power minus 2. Okay, and then I am going to write 1 by 2 raised to power n u of n minus 2. Okay, then what happens? Then this can be written as, this will go in the denominator, okay, and you can basically write this as n minus 2, or let me write it like this. Okay, what is 1 by 2 raised to power n minus 2? What is that? That is basically equal to 1 by 2 raised to power n into 1 by 2 raised to power minus 2. And what is that? That is 1 by 2 raised to power n multiplied with 2 raised to power 2. Correct? So if I multiply this function with 2 raised to power 2, I will get 1 by 2 raised to power n minus 2 u of n minus 2. I will get that. But since I have multiplied with this, I have to also divide it with 2 raised to power 2, which is 4, isn't it? So I can write this whole function itself as 1 by 4 into 1 by 2 raised to power n minus 2 u of n minus 2. Okay, and then the just previous problem that we did, we first find out 1 by 2 raised to power n u of n, what is the Z transform, and then we apply the time shifting property to find out what is 1 by 2 raised to power n minus 2 u of n minus 2. Okay, and then we just multiply the answer with 1 by 4 so that we get the final answer, 1 by 2 raised to power n minus 2 u of n minus 2. Now we have already done up till this in the previous problem, isn't it? This was exactly that problem, isn't it? So we have got the answer also. The answer is basically this. Am I correct? So let me, if I just write the answer here, the answer for the Z transform, let me just write it like this. So 1 by 2 raised to power n minus 2 u of n minus 2, I have already got the answer in the previous one, which was 1 divided by z into z minus 1 by 2. Am I correct? Yes, with ROC z greater than 1 by 2. So with ROC of z greater than 1 by 2 outside the circle. So this one step is multiplying it with 1 by 4. So here also I will multiply it with 1 by 4, and this is what is going to be the answer. Okay, but this is one of the methods. Let me use the first method that we have studied. Let me use that. Okay, because this one just now we did. Let us get the original answer by doing this method. Okay, so I'm not going to use this method. I'm going to use the first method that I have just now said. So now solution of this one will be, first we know u of n, the Z transform is z divided by z minus 1. okay, with ROC Z greater than 1 outside the circle. Okay, next we apply the time shifting property, time shift property. And what is the time shift property? What is the time shift property? That if you are having a function x of n, if you shift it by x of n minus n naught, then all you have to do is multiply with z raised to power minus n naught, the original x of z that you just now got, and the ROC remains same, except that either an addition or deletion of 0 or infinity will be there. So let us look at that. So according to this, u of n minus 2, the z transform will be z raised to power minus 2 z divided by z minus 1 with ROC being z greater than 1, and similarly here z square is going to be 1 divided by z square, so z should not be equal to 0, which actually is being taken care here itself, isn't it? Because this is outside the one circle, already z is equal to not 0 in region of convergence, so there is no need to add specially. Okay, so this is only going to remain the ROC. Let us reduce this one. This one is going to be 1 divided by z into z minus 1. Am I correct? Next, we apply the multiplication by exponential function, exponential sequence. So apply multiplication by exponential sequence, which says that if you are having a function x of n whose z transform you already know, and if you multiply that with a raised to power n, then all you have to do is you have to, instead of writing it as x of z, you will have to substitute instead of z, z by a, and in the ROC also you have to take care of that you are going to divide z by a. That means ROC is going to be again a multiplied with the region. Okay, that is what is the original property. So based on that, if I am going to have 1 raised to power 1 by 2 the whole raised to power n u of n minus 2, then instead of z, this is the function now I am having, so instead of z I will have z divided by a. Now what is a here? 1 by 2, which becomes 2z. Why? Because z divided by 1 by 2, that becomes 2z, isn't it? So that is what I am going to write. Instead of z here I will just write 2z. So this is going to be 2z, and this is going to be again, sorry, color is changed, this is again going to be equal to 2z minus 1, and instead of, in the ROC also, instead of z I will write magnitude of z divided by a, which is 1 by 2, which again divided by 1 by 2, which again becomes 2z. So I will straight away write 2z should be greater than 1, or z should be greater than 1 by 2. Okay, so if that is the case, then let me write this one. This one will become let me rub this part so that I will rewrite that. Let me first solve this. See here I will take 1 by 2 outside. So first 1 by 2 outside I will take. What remains is 1 divided by z, and then here also I will take 2 outside. So what remains is z minus 1 by 2. So that 2 also if I take outside, then this 2 into 2 will become 4. So let me write that properly. I will write this as 1 by 4 into this. See, 1 by 4 I could have also written here. Okay, but for the time being, let me write it here. So 1 by 4 into 1 divided by this, where the ROC is now, ROC we saw is 2Z should be greater than 1 or Z should be greater than 1 by 2. Therefore, finally we can write that 1 by 2 raised to power n u of n minus 2, the Z transform will be, this 1 by 4 I will write in the numerator, divided by Z into Z minus 1 by 2, with ROC value being Z greater than 1 by 2. See, if you remember, when I started this problem, I said 2 methods. And in the second method, I had already got the answer. The answer was the previous problem. Here, instead of 1, I had written 1 by 4. And what was that? In the denominator, Z into Z minus 1 by 2, ROC is this. You remember? The second method. But I used the first method. Now look at what is the answer of the first method. It is the same that I had found out using the second method. Correct? So you use any of the methods. It does not matter. Whatever you find convenient, you use it. But obviously the method should be correct. Then whatever property sequence you are applying, that should be correct. And the final answer should be correct because of that. Okay. We will stop our class here for today. We will do more problems in the next class. Thank you.